Hi, it's Graham Cox here, co-founder of OptiSurface, and I'm going to give you a quick demonstration of how OptiSurface Designer can be used to design erosion control structures, including the powerful runoff velocity simulation. So this is the site. We have a gully dam, the embankment here, and it stores water in this area here. This is actually a effluent pond for a feedlot over here, and this is just a shallow water storage. Each one of these grids is 100 meters or 300 feet. So the spillway for the dam is here, but it was having problems discharging to the gully here without eroding, so that the spillway had to be redesigned. We calculated the peak discharge for a 100-year storm event, and that's using some engineering hydrology for a catchment which goes further upstream. And based on the rainfall properties in this area, the peak discharge for a 100-year event was 120 cubic meters a second. That calls for a spillway of 220 meters wide, or 660 feet wide at the crest, and then we've got to take that safely down to the gully. If we look at the existing topography, it looks like this. This is actually LiDAR data, and there was some trees in here, so that's why the LiDAR is a bit messed up. These spikes are actually trees. And this is more like top water level of the dam. Our area of interest is through the spillway here, so you can see this is the erosion gutter that was happening, and here from the spillway, so we need to get that under control. The design we came up with was like this. This is where it's 220 meters wide at the crest, flat crest area, and then a return slope, take the water back down to the gully. If we look at the long section down the center there, it's got a flat area at the top. So we've got a flat area, then we drop off. In the center of the spillway return slope, it's about 0.5% slope, and then drops about 1% at the end back to the gully. And you see we're filling this deepest point, we're filling about 1.5 meters, 5 feet. No other software gives you the ease and flexibility of designing erosion control structures like this, but the real unique power of OptiSurface in this case is that we can simulate runoff velocity down that spillway. The way we do that is draw in a zone and enter a flow. In this case 120 cubic meters per second. That'll discharge out of that zone and start flowing with the topography. You can see we've built up a high ridge around the outside. That's artificial, obviously we haven't built that in real life. That's just in there for the modelling to get the water to flow this way. Otherwise, if we don't have a ridge there, the water will just flow out of the model that way. So we build that up, water will build up in here and flow down the spillway. While we're here, we might as well look at the design in 3D. This is the other effluent storage that was over here. And this is the spillway, obviously, and this is the embankment that exists for the gully dam. Once we look at our runoff analysis tool, we can select the proposed topography to do our analysis on, or the existing. Calculation grid's 15 meters. We're just simulating a 1 hour event. These are important when you're simulating runoff for a field, say, but in this case where we're entering the discharge or the flow rate via this input here, these aren't even used. So I've set the runoff coefficient to 0 for the rest of the area, so the rainfall's not doing anything effectively in this case. We've got a hydraulic roughness of 0.03, which is appropriate for the reasonable good grass cover over the spillway, and we click calculate. It doesn't take long to simulate because basically it's just the time for that 120 cubic meters a second to build up here and flow down the spillway. This is simulating 1 hour in simulation time, so water's flowing for an hour, and this is the result that you get. We've got this runoff velocity of the water. We're trying to keep the velocity below about 1.5 meters per second. We can see, just ignore that, that's where the water's just coming out of the inflow zone, but this is where we're interested. We can see here that we've got up to 1.75 meters a second. The blues are 0.25. Then down the bottom it builds up again as it drops into the gully. If we look at the runoff depth, you can see it's about 0.5 meter deep here, and then as it flows down it gets shallower and then gets the gully. Look at all of this in 3D, get a feel for what's happening, where the high risk areas are. And this area here, can't really reduce that too much. We're constrained by how quickly we can, by the slope of the topography here. There's no real quick fix for that. We may have to put some extra protection in here to ensure that doesn't erode. The rest of this area will be right for grassing, as long as the grass is kept in good condition. Then we can look at the cut fill map, which shows you the areas that have to be cut. Soil has to be cut from and the fill areas. So the green area is neutral, and then the yellows and reds are cut areas, and the blues and purples are fill areas. So we've got an embankment along here to keep the water into the spillway. See, filling this gully back in, and the earthworks are shown here. It's about 20 hectares, 50 acres. We've got about 33,000 cubic metres, similar yards, cubic yards. Okay, thanks for watching. I hope that's been useful, and send any questions or thoughts to support@optiservice.com and we'll get back to you as soon as we can.